Hello viewers, welcome to Young Maths Academy. Today's another class, and we are to learn how to prove statements in mathematics today. And we're learning how to prove by mathematical induction, or simply induction. Induction is a mathematical proof for all natural numbers, for all positive integers. Okay, we have a question on the board, and if you can see this very well, we have this question that's proved by induction that summation r from 1 to n of r squared is equal to 1 over 6 n plus 1 into 2n plus 1. Okay, so let's see how we solve questions like this. We prove statements like this. Okay, all right, proof. So in mathematical induction, there are basically 3 steps. Okay, and the first step is to check when n is equal to 1. That is, we prove when n is 1, where to know if the left hand side will be equal to the right hand side. While step 2 is to assume. We take an assumption when n is equal to k. That is, we assume when n equal to k to be true. While step 3 is to prove or show that n equal to k plus 1 is true. And after getting that to be true, then we write our conclusion. Okay, just with this, you will be able to get the whole concept about using mathematical induction to prove statements. So here, step one. So when n is 1, when n is equal to 1. So I'll start with my left hand side. So left hand side, I have summation r from 1 to n r squared. So this is simply summation r from 1 to n. So I'm substituting n for 1. So that simply means I am saying of 1 squared, which is summation r from 1 to n of 1 is equal to 1. Okay, when r is 1, n is 1, the same thing as substituting n here to be 1. Means r is exactly at 1. R is at 1, and when r is 1 in a function, this is a constant function, 1. So the sum of these will leave us with 1. So we have 1 there. Okay, so right hand side, we have 1 over 6n, n plus 1, 2n plus 1. Okay, so I'm substituting 1 for n here. That means I have 1 over 6, 1 plus 1, 2 into 1 plus 1. Okay, so that this leaves me with saying 1 plus 1 is 2, 2 times 1 is 2, 2 times 1 2, plus 1 3, 3 times 2 is 6. So I have 6 over 6, and 6 over 6 is 1. Okay, very good. So we can see here that our left hand side is equal to the right hand side. So left hand side is equal to right hand side, since we got 1 for both sides. So that means it is true. It is true for n equals 1. So this is true for n equals 1. Okay, so we go to the step 2. Okay, so because of space here, we have to clean this. So I will just rub off my step 1. So step 2 is to assume n equal to k true. So we assume n equal to k is true. Okay, so assume step 2. We assume n equal to k is true. So assume n equals to k true. So here simply means I'll substitute that here. I have summation r from 1 to n r squared is equal to, I'll put that in my right hand side, the expression I have there, 1 over 6 into k plus 1, 2k plus 1. So I can just label it I, okay, 1, so that I will say it is true. So this is true, since we just assume that. So it's an assumption. So we go to step 3. So step 3 is when n equals to k plus 1. N equals k plus 1. Okay, so when n equals to k plus 1, I'll just substitute that. I'll write summation r from 1, n is k plus 1, r squared. So we have to show this left hand is this. Okay, we are dealing with this left hand, which is this using k plus 1. So I can write my k plus 1 summation of the out from 1 to k plus 1, the k plus 1 term, as the sum of the kth term and the k plus 1 term. So I'm going to write the sum of k plus 1 as sum of kth term and the k plus 1 term. And this is what I mean. I'll write this as summation from 1 to k. Means that I can just say from 1 to n r squared, because this represents the kth, the sum for the kth term, which is in equation 1 when we assume n equals to k. N is just like n is k here, but we don't replace it there, so we just write it this way, plus the k plus 1 term. Means I'm going to substitute k plus 1 here, so it means I'll write k plus 1 squared, just this way. Okay, so that's here now. From this point, I will substitute this with my equation 1, since this summation r from 1 to n r squared is this. So I can substitute that. Okay, I will just have to rub off this here, so that now I have that to be that I'll just write this here, that summation r from 1 k plus 1 of r squared, which is equal to this. So this is 1 over 6 from step 2, k plus 1, 2k plus 1, then plus, so that is plus k plus 1 squared, k plus 1 squared, just this way. Okay, so that this is equal to, now I can take LCM of both sides, so LCM of this expression here, rather, so that I have this as 1 over 6 into k plus 1, 2k plus 1 plus 6k plus 1 squared. Taking the LCM there, I will come out with this. So that from here, I can factorize. K plus 1 is common, so I have 1 over 6, k plus 1 out, so I have k, and I have 2k plus 1, okay, plus 6 into k plus 1, just this way. Okay, very good. And above this, so that with this I have that 1 over 6, and this is same thing as k plus 1 is common, so that is out, so like this. Okay, so I have k plus 1, so here I'll expand this. This is 2k squared plus k plus 6k plus 6, just this way. So I have this. This is k plus 1, k plus 1. Okay. So this is simply still the same thing as 1 over 6 into k plus 1. Now this is 2k squared plus 7k plus 6. Okay, just this way. Okay, I can have this way. Now I'm to express it in this form, so I will have to factorize this. This is a quadratic expression in here. Okay, so that I'll rub off this top, so that I have this to be 1 over 6 k plus 1. Okay, 1 over 6 k plus 1. And this is same thing as, if I factorize this will be 4k plus 3k. Okay, so I have 2k squared plus 4k plus 3k, then plus 6, just this way. So that this is 1 over 6 into k plus 1. This will be 2k is common, so I have k plus 2 plus 3 is common, k plus 2, this way. Okay, this way, so that this is same thing as 1 over 6 into, okay, this is k plus 1, so k plus 2 and 2k plus 3, just this way. Okay, so with this now, and we are to express that in form of 1 over 6 n plus 1 to n plus 1. So that will make me write this as 1 over 6 into k plus 1. Okay, I can write k plus 1 as k plus 1, open a bracket and close it here, plus 1. Also, this I can write this as 2k plus 2, just like this, then plus 1. I have this, and this is same thing as 1 over 6 into k plus 1, k plus 1 plus 1. So this is 2, k plus 1 plus 1. So now this is exactly just like this. So because when n is k plus 1, so it's simply n plus 1, 2n plus 1, just like this. So it is true. So here we write our conclusion. It is true for n equals to k plus 1. So if it's true for n equals to k plus 1, that simply means it is true for all natural numbers. Hence, true for all n in n. So that will be our conclusion. So we've been able to show that by induction, that summation r from 1 to n r squared is equal to 1 over 6n into n plus 1 into 2n plus 1. Okay, yeah, thank you for following through the video. This is just the basic concept about proof by making use of induction. I want you to follow through through in the subsequent videos and see how we solve other questions on mathematical induction. Thank you for watching. Subscribe to my channel, Young Maths Academy. Thank you.